This lecture is about measurement and the uncertainty that can be part of measurements. Or the goals that you should be able to do at the end of this lecture are to distinguish measured from exact numbers and to be able to record a measurement properly, either a measurement taken with a digital instrument or with a lined instrument. And once this measurement has been recorded, be able to identify the level of uncertainty that's implied in the way that you record the measurement. One of these goals is found on page 6 of your packet, the list of goals for Chapter 1. We have a little bit from Chapter 1 here, distinguishing an exact number and a measured number. Then on page 16 of your packet, where the goals from Chapter 2 are, we're going to be looking at the correct way to take a measurement and also knowing the uncertainty or the number of significant figures in the measurement we have just taken. So this topic is found in LibreText on this text page here, 1.4. There is another video that's also very relevant for this topic, and there are some practice problems in the Module 1 practice page that have to do with looking at instruments and taking measurements. You may notice in the LibreText agenda that in addition to my lectures, I have some other video links. A few of them are taken from this Mystery of Matter series. It's a PBS series that's really amazing. If you want to check out more of it, you can go to mysteryofmatter.net. But we're going to watch a few clips, some of them having to do with Antoine Lavoisier. He's sometimes called the father of modern chemistry. Chemistry is the study of matter and its changes. So an important step in the history of chemistry was to figure out what matter was made of. And it's been a long process, but Lavoisier helped it along specifically by being careful about measuring things. His measurements helped to topple the reigning theory at the time that had been around for 100 years, the theory of phlogiston. And he did this by taking very careful measurements of the ingredients of his experiments and the products. This shows how important it is in chemistry and in science to take careful measurements. We should know that a measurement is not just a number. So you might look at a measurement like 52.7 milliliters and just focus on the number, but do remember that the units are also very important, and the uncertainty that you represent is also very important. So if you report something as 52.7 milliliters, then we are assuming that that last digit that you report, the last significant digit in the number, is where your uncertainty is. So you weren't quite sure about that 7. It might have been a 6, it might have been an 8. So this volume measurement could be plus or minus 0.1 milliliter. That's what you are implying when you give that uncertainty. If instead you had reported it as 52.70 milliliters, then that 0 would be uncertain. So you're not quite sure of that 0. It could be 0.01 less. It could be 52.69 milliliters, or it could be 0.01 milliliters more. It could be 52.71 milliliters. And so if you report something as 52.70, you have a much narrower range that you're saying your measurement can fall into. Instead of, if you report 52.7, this is a much wider range. So 52.7 is plus or minus 0.1 milliliters. So it could be as much as 52.8 milliliters, much higher than 52.71, and it could be as low as 52.6 milliliters, so lower than 52.69 milliliters. Even though your calculator would treat 52.70 and 52.7 as the same numerical value because they are equivalent, the meaning of 52.70 on an uncertainty level is a little bit different from the meaning of 52.7. Of course, if you had 52 milliliters, then that is plus or minus 1. This could be 53, or it could be 51 milliliters. Then this is plus or minus 0.001 milliliters. So it could be as high as 52.757 milliliters, or it could be as low as 52.755 milliliters. All right, given what we were saying about the certainty of measurements and that the uncertainty has to be in the last digit, that affects how you record a measurement when you are measuring something. For instance, when you are using a digital instrument, let's say you have a balance and it records something as 17.26 grams. So a digital balance here, recording something as 17.26 grams. If that is the limit of the display, that it only goes 2 past the decimal, then that's because the instrument, the way that they manufactured it, cannot really tell the difference more finely than this. So let's say that you are taking this measurement with a digital balance that goes 2 past the decimal. Then a mass that is 17.2586 grams will show up as 17.26 grams. Also, a mass that is 17.2633 grams will also show up as 17.26 grams. So the uncertainty here is in this last digit. It could be a 5, it could be maybe even closer to round up to 7. This is the uncertain digit. It's not 17.260 for sure. It's 17, it could be 17.25 something, it could be 17.26 something. So this is the uncertain digit for a digital balance. So we use all digits in the digital display, and the last digit given in the digital display is where your uncertainty is. Let's take a look at a ruler measuring centimeters instead of a digital balance measuring grams. So this ruler is measuring centimeters. We have this line being 17.0 centimeters. The lines on this ruler are every 0.1 centimeters. So we are going to estimate this red piece of string is what we're measuring here. We're going to estimate the length of that piece of string to the 0.01 centimeter. So we can see that it's between the line for 17.2 and 17.3. So there's not really any uncertainty there. Everybody can see that it's between those two lines. It's 17.2 something. The something is where the uncertainty is, because some people might estimate this as 17.26. Other people might say that this is 17.27. Some people might say it's 17.25 centimeters. This digit is the one that's uncertain. Hopefully, no matter what people estimated, they would have the 2. The 2 is something everybody would have. The 6 is not something everybody would have. Some people might have 17.27. Some people might have 17.25. That's the digit that is a little bit uncertain, because there is not a line on this particular ruler for 17.26. So that 6 is a little bit uncertain. That's estimated. So you should be going one place past. From the 10th place where every line is, you're going to record to the 100th place, kind of like this table is showing. So if this is where the lines are, you are going one place value to the right. So from the 100, you're going to record to the closest 10. From the 10, you would record to the closest 1. So that lets you do an estimation and get an uncertain digit. So if you had a slightly shorter string, and you thought it was exactly matching the line for 17.2, still the 2 is not uncertain. Nobody would say the pink string was 17.3 or 17.1. So to show that we can estimate to 0.01, we would record the pink string as 17.20 centimeters. But this is about how sure we are of the pink string. If we recorded this as 17.2, then we are saying that it could be 17.3 centimeters or it could be 17.1 centimeters. And I think that we can see that we're a little bit more sure of the pink string than this measurement would seem to indicate. This one is a better measurement. All right, let's get some practice with taking measurements on these lined instruments. We have two types of rulers here, and the same ruler is measuring two different rectangles, and then we have these two measurements with this same ruler measuring two slightly different rectangles. I did put that these rulers are centimeter rulers so that you could put the units as well. So these rulers are marked every 1 centimeter. There's a line every centimeter. There's a 33 and a 34. There's not a 33.1 or a 33.5. So for this ruler, the lines are every 1 centimeter, and we are going to record to the 0.1 centimeter. And for this ruler, the lines are every 0.1 centimeter. The numbers are every 1 centimeter. There's a 16 centimeter and a 17 centimeter, but there is a line for every 0.1 centimeters. This one is between 33 and 34. I'm going to estimate that at 33.7 centimeters. If you put 33.6 or 33.8 or something else in that space, it's still correct. It's still a correct measurement. That's the uncertain digit. This one is supposed to be on the line. So to show that it's on the line, we're going to put this as 34.0 centimeters. If you thought it was a little short and put 33.9, that's still okay. 34.1, I guess, would also be okay. And even though the rectangles are a different length, they're both recorded to one place past the decimal because they're taken with the same ruler. We have a similar situation here. We have a line for 16.7 and 16.8 centimeters. It's in between, so we're going to say this is 16.75 centimeters. That 5 is estimated. If you did had a different estimation, that is also okay. This one is on the line for 16.8, so we're going to put this as 16.80 centimeters. Because we're uncertain of the 0, you might have said that it was 16.81, but we're not uncertain about the 8. Hopefully you didn't put something different from an 8 there. A lot of times someone will say, oh, it's exactly 52 milliliters when a measurement happens to be a whole number, let's say 52 milliliters, as opposed to 52.7 milliliters. And if this is a measured value, then it can't be exact. So 52 milliliters is not an exact value. Over here we saw that it meant between 51 and 53. Even if we had a more precise measurement like this would still be plus or minus 0.001 milliliters. So something that is measured cannot be exact. Exact meaning no uncertainty, because that's the definition of exact. It means that there's no uncertainty. Whereas every measurement, even if it's fairly good measurement, like this is a really excellent measurement, it still has some uncertainty. You can't have no uncertainty for a measurement. But it is possible to have an exact number, something with no uncertainty, and that occurs when you count something If you count something, it's 4 beakers or any other thing that you count that has to come in whole numbers, like a beaker has to come in a whole beaker. Either there's a beaker or there's not a beaker. It's not that there's 0.001 beakers somewhere. So if you're counting something, this has to be exactly 4, not 4 plus or minus 0.01 or 4 plus or minus 1. It has to be exactly 4. Another way that you can have this is if a value is defined. A lot of times this happens with a relationship. The definition of 1 kilogram is exactly 1,000 grams, and that's the meaning of that unit. It's defined that way, and so it is exactly 1,000, not 1,000 plus or minus 0.001. So it is possible to have an exact number in these two cases. So that is the material on measurement and uncertainty for that topic. The other material that we have available on this topic are some practice problems in LibreText, and also there's a Canvas assignment that involves being able to measure things properly.